gang, welcome back to the channel. Today we're talking about Exam 2 review, and this review is proudly sponsored by me. Go on Amazon and pick you up a copy of my engineering notebook. You're looking for a notebook to take notes in class in? This is it for you. It's on Amazon right now. Link in the description below. Graph paper on every page. You get bored waiting for class to start, boom. Sudoku puzzle. There's about 10 of those in this book. There's also, in this book, secret study tips. I'm not telling you what they are. You got to get the book to see what they are. Okay? So go to Amazon.com. Help support the channel. Get a notebook. Get one for every one of your classes. Look, you can put whatever class you have right here on the front of there. Keep it all nice and organized. Support the channel. Thanks for all you do. Let's get to this problem. Okay, today we're talking about torsion. We're talking about gear ratios. This is one of the hardest problems that you can have on your next test. So I'm trying to get you ready for that. Let's see if we can figure it out. Sweetie, you go somewhere else. All right, Sweetie's not going to help. Here we go. How do you do these problems? Okay, you've got a fixed support at the wall here, fixed support at the wall there, and you've got a shaft that has in the middle a gear on it with a 15 kilonewton meter torque applied to it. Now notice I've got two gears over here that are different size. That's where I get the gear ratio problem, okay? So the first thing you got to do on these problems, number one, free body diagrams, just like good old statics problem, right? Let's break this into two parts. I'm going to draw a free body of this system up here and then one of that system down there, and I'm going to get some equations from that. Let's go, okay? So equation number one, here we go. Okay, mirror. This is pretty good for quickie, okay? So there's the system number one, and then system number two maybe is down here. Okay, there's system number two. Wow. Okay. So down here I've got this guy. Now what do I have down here on that free body down there on the bottom? What do I have? Here's what I have. I have a reaction force at the wall. Well, let's start up here where the torque is applied. I have up here, let's do it a different color, right? I have this, okay, 15 kilonewton meters. Now, right off the bat, don't make this mistake, okay? This is easy to do. Look, that's kilonewton meters, and all of this stuff here is in what? It's in millimeters, isn't it? How easy is that going to be to get a mixed unit? Way easy. Don't do it, okay? So, you know what I'm going to do? You know what I'm going to do? I'm just going to automatically, smudgy. I'm going to add 3 zeros to this and make it kilonewton millimeters, okay? I think that'll help us over there, okay? So that way everything's in the right units, okay? All right, now over here, if this thing twists that way, which if I'm looking at it, here's my eyeball, let's say, okay? And I'm looking at it this way, I would say that that's clockwise. So the wall resists that, and so the wall, I think, is counterclockwise. Let's just call that TA, torque at point A, okay? Now what's going on over here, okay? This thing wants to rotate counterclockwise. Do you think that gear is going to allow me to rotate counterclockwise? Again, this one's fixed to the wall. He's going to resist everything I do. So this one tries to make me spin this way. I think that this gear down here tries to make me spin that way, right? It's opposing it. I feel that force that's twisting the other way. It's opposing that force. Now this guy down here, he's going to have the opposite. What does he feel? He feels this guy rotating and pushing that way on this gear, right? These two have to be opposite, don't they? Okay? And then what happens over here? If this rotates me this way, which again, if my eyeball is looking towards the system this way, I would say that that's counterclockwise. And so then this guy over here has to be clockwise, and we'll call him what? R-E. Or, I mean, let's say, not R, T-E. Smudgy. Why is my pen smudging so bad? Ugh. Okay. T-E. Okay? So there's my free body diagrams for this system. That's it. Are you good so far? Did you get it right? Okay, let's write some equations for this. Now, this system by itself, it's hooked to the wall. It's not spinning. So what does that mean? The sum of the moments has to be 0, right? Sum of the moments for this guy has to be 0, right? So the sum of the moments for this problem down here, sum of the moments equals to 0 equals what? F times force times distance, right, makes moment, yeah? So force times what? What's the distance? 100, right? So F times 100, okay, is rotating me one way, and then this guy rotating the opposite direction, so I'm going to just put minus TE. Now, TE is already a torque, a moment. It's already in moment, right? This is force times distance, which is moment. So I got moment and moment, okay? So for this equation, I get TE is equal to F times 100, or F is equal to TE over 100. Okay. Let's go up here and see what we got. Okay, same situation. TA, again, I'm thinking that's rotating counterclockwise. I'm going to call him positive, okay? So TA, the 15,000 is rotating the other way, so minus 15,000, right? And then I got F, which is rotating same direction, so plus F times how far away? 50, okay? And all of that has to equal to 0. So what do we get here? Well, you know what we get here? Let's take that equation. Let's substitute this in for F, and let's write it that way. So TA plus, I'm substituting, TE over 100 times what? I just substituted right there. So times 50 has got to be equal to, let's move this to the other side since he's a negative. There you go. And so let's see, so TA equal, plus TE over 2, right, equals 15,000, okay? Boom. Equation number 1. Let's see if we can come up with an equation number 2 using the gear ratios. Okay, now that we've got equation 1 derived, we need, because our equation 1 has 2 unknowns in it, we need an equation number 2. Now, where's that going to come from? Equation number 2 is going to come from these 2 gears right here, okay? So we have one gear interfering with another gear, and so this is what we call a gear ratio problem, okay? So number 1, what is the gear ratio? So let's think about this. We have gear C and we have gear D, okay? So let's just think about it like this. Here's gear C, okay, and here is the deflection in gear D. So remember, phi is the angle of twist, remember? Okay, so how do I make this equality here true? Because remember, if C rotates 180 degrees, what does D rotate? Well, since it's 2 to 1, it's only going to rotate 90 degrees. So if I want D, right, the rotation of D to be equal to the rotation or the angle of twist of C, what do I need to do to make that equality true? Okay? Now this is a 2 to 1 gear ratio because it's 50 here and 100 there, so it's 2 to 1, it's twice as big. The easy way to remember this is the gear ratio number, the 2, always goes on the big gear, always, okay? So phi, the angle of twist of gear C, is equal to 2 of the angle of twist of gear D. Now this is going to be where our second equation is going to come from. So let's write the phi equation. You remember this from way back, right? Phi equals TL over JG. Torque times length divided by the polar moment of inertia divided by G, the shear modulus of elasticity, okay? So I'm going to fill in this equation here for these 2 phis, and hopefully that gets me an equation with TA's and TE's in it, and then I'll have equation 1 and equation 2, and then we can solve it. All right, here we go. So let's do, this one's the easy one, right? And for this guy here, for gear D, right? For gear D, what kind of torque is gear D seeing? Okay. Now we can go to this free body right here, and let's just cover this up. What torque is in this gear, is in this shaft right here? Well, the torque is TE. It's got TE in the whole thing, right? So on this side, I'm going to have the T is going to be TE, okay? And what's the L? The L is the length of the shaft, which is, bam, right there, 500, okay? And then divided by, I'm just going to put JG, okay? Now, I can look up the material of this shaft, and I can tell you all kinds of things about that, but I think that every single term in this equation is going to have JG in it. I think it's going to divide away, okay? Let's check and see if that's true. So what goes on the other side? Now, this one's a little bit trickier, right? Because this guy has two sections. He's got a section here and a section here, so I'm going to get a little angle of twist here and a little angle of twist there. And to get the total angle of twist of this gear, I have to get the total angle of twist of that shaft. So I'm going to do this in two parts. I'm going to do, this is piece number 1 over here. We'll put a little 1. Burp, burp. And this will be piece number 2, okay? So piece number 1, again, cover it up. What's the torque in piece number 1? Well, it's TA, isn't it? So TA times, right, TL. L is 600 divided by, here's that JG again. We're okay there. Now let's do the second one, plus, what's the torque in this section here? Okay, let's cover it up and let's look at what's the torque, the total torque. I think the total torque is TA minus 15,000, right? So TA minus 15,000. Ooh, our equals is too big. Times how big? How much length, right? Our L is what? 700. 700. Divided by JG, right? So there's angle of twist in this section. Here's angle of twist in that section equals the angle of twist in that section. Okay? Oh, we forgot one thing, didn't we? What did we forget? We forgot that guy, right? We get our angle of twist. We've got to multiply it by 2 to make that side equal to that side. Okay? Let's simplify. Okay? You're gone, you're gone, you're gone. So let's see, where am I going to go? I'm going to go over here. Okay? So I get TA plus, 600 TA plus what? 700 TA minus, 7 times 5 is, 15 is what? 70 and 35, 105, 105 with how many zeros? 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5. Okay, is equal to what? 1,000 TEs, right? 1,000 TEs. Okay, now what? I got 2 TAs over here, so this is 1,300 TA minus 1,000 TE is equal to 10,500,000. Can I divide everything by 1,000? So 1.3 TA is equal to minus TE is equal to, get rid of 3 zeros, bloop, 10,500. And there's equation number 2. Okay? Are you with me? Okay, now let's erase this guy just so we have some room over here. We have one more step. We've got 2 equations. We have 2 unknowns. We just got to do a little substitution and we're done, okay? So here's equation number 1. TA, let's just make that equal to, let's just do, can we multiply everything through by 2? Can we put a 2 there and get rid of that and put a 30 there? Okay, just multiply everything in that equation by 2. And I'm going to solve that equation there for TE. So TE is equal to 30,000 minus 2 TAs. And then look at this equation down here. I'm going to make him equal to TE, you know? So TE is equal to, move him to the other side, 1.3 TA minus 10.5. Okay? Oh, look at that. Now we can set those two equations equal to each other here. And then all we got is TA, right? Here we go. 30,000 minus 2 TAs must be equal to 1.3 TAs minus 10,500. Okay, let's see. All right, so let's get the TAs on one side here. Okay, so we're going to move this over here. This becomes 3.3 TA. And then let's take that to the other side. 30,000 plus 10.5 is 40,000. 40 is, it looks like that. 500. Okay. And then what? Let's get that over there. So 40,500 divided by 3.3 equals, woo, 12,272. And remember, 0.7 kilonewton millimeters, right? Or 12.3 kilonewton meters. Okay, that's TA. Now, once I have TA, how hard is it to get TE? Okay, well, I just multiply TA times 2. So times 2 is 24,545. Then move that to the other side, subtract it off of 30. So 30, 1, 2, 3, minus answer equals 54.54. What? That's such a cool number. Okay. TE equals 54 kilonewton millimeters, or 5.45 kilonewton meters. Okay? So there's the reaction at E. There's the reaction at A. And the last thing we need to do is this guy right here says find the angle of twist of gear B. Now remember, the angle of twist of gear B, okay, is the angle, this gear is going to twist as much as this shaft section right here will, right? So what is the angle of twist of that section? Well, it's not 13.5, that's for sure. What is the angle of twist in this AB section? Well, it's the torque at A, isn't it? And the torque at A is where to go. There he is. 12,272.7. 12,272.7 kilonewton millimeters. This is important. You got to get all this to cancel out, okay? Now, I'm going to erase this too. Oh, no, I'm not either. I need to get rid of that kilonewtons also, right? So a kilonewton is what? 1,000 newtons, okay? So I'm going to put 1,000 on the top up there. Okay, so now I'm in Newton millimeters. What do we know about Newton millimeters? Remember pascals and that kind of stuff? Okay, now on the bottom I've got J and G. Okay, now G is 79 gigapascals. Now where in the world did that number come from? That's a look 'em up, right? You're going to look that number up in the back of the book under the shear modulus elasticity. That's G, okay? And it's 79 gigapascals. What's 79 gigapascal? That's 79, 1, 2, 3 zeros megapascals. And what's a megapascal? Do you remember? Newton over millimeter squared, right? Newton over millimeters squared. Now that's handy because I have newtons up here on the top and millimeters, right? Everything's in newtons and millimeters, so it all should cancel out, okay? By the way, what's phi going to be in? Do you remember? Radians, right? Everything cancels out. Okay, and then there's J. Here, let's do J right here. J equals, do you remember the equation? It's pi over 4. No, it's not pi over 4. Remember, it's pi over 2. How do I remember it's 2? Look, J only has, bam, bam, 2 ends on it. I has 4 ends on it, doesn't it? Times R. What's the R is, oh, they tried to trick us, didn't they? They gave us the diameter. but we need the radius. So R is 12.5 to the fourth. Now this is a solid shaft, so that's it. And this answer is going to be in millimeters to the fourth, right? So 12.5 to the fourth power. Okay, times pi times 3.14159 equals, and then divided by 2. Divided by 2 equals 38,349. Well, 0.5 millimeters to the fourth. So that's J. So that goes right here, right? So 38,349.5. Okay? Now, all we have to do now is put all of that in our calculator. Our units are all good. They all divide away. And that's going to give us an answer in radians. So let's see if we can do it. Here we go, gang. 12. 272.7 divided by answer equals divided by 79,000 equals times 600 equals times 1,000. Don't forget about it. He's hidden over there my terrible use of my board here. Woo! Which equals 2.43 radians. Wow. 2.43 radians. That's a lot. Okay? Why is that a lot? Well, because this is a gigantic force. 15 kilonewton meters is a gigantic torque. But that right there is going to be phi of gear B. Okay? All right. Did you follow along or did you get lost? I hope you followed along. This is about as hard a question in torsion with gear ratios that you could possibly get on a test. If you can do this, everything's going to be easy. All right, I hope that helped, and I'll see you on the next video.